Thank you, Pete, and the team for putting this together. I'm so excited about this. And so my talk today, the title is Enterprise Data Science Comes of Age. And in the abstract, there's a list of things that I wanted to talk about that I thought would be interesting to this audience. And I do recognize that this is, the Data Council has much more of a data engineering and data-oriented focus than maybe some of the more data science and machine learning kinds of things that I tend to frequent. So I wanted to really cover a breadth of topics. Python, where did Python come from and how did it get so popular? Why are you guys having to fight dependencies all the time? Isn't that on there? Okay, well, ML ops, I guess we call it now. This sounds cooler than fighting dependencies. But then open source innovation, how that happens. And then what does the future hold for democratized AI, right? Now, there's a lot of stuff, and they all sort of like interconnect with each other. So to frame it better, I thought I would use a more familiar backbone to tell the story. And if you guys have ever heard of this thing called Star Wars, you sort of start with, like all great stories, start with episode 4, where a new language emerges in the scene for data processing and whatnot. And then as it gets enterprise adoption, right, how does it have to change? What does it mean when enterprises really start adopting your technology? And then lastly, what does the future look like? And just to give it away a little bit, I think the future we're heading into is a cybernetic one. And what does that mean? Like, is that like just a bad sci-fi movie trip? Or like, what does cybernetics really mean for us? I thought it was about AI, right? So this is going to be the structure of the talk. And so, of course, you can't do Star Wars without doing a little bit of a text call. I don't know if you guys see that in the back, but it's really funny, I assure you. At least when I wrote at 1 a.m., it was really funny. But the general concept here is that when we started a lot of this stuff, pushing Python for data, and as Pete mentioned, the PyData stuff, we started getting all this going about 10 years ago. It was kind of a rebel thing. It was like this weird thing. It's like Python, I thought that was the Ruby alternative. Obviously, Hadoop and R, and these are the things that are going to be the future of data. And me and a few other people were like, no, Python's kind of a thing. So this first section, episode 4, is how did Python actually take over? How did it actually come to pass? So back in 2012, I had this thesis that there was a double disruption happening in the, industry, broadly as a term, but really in business and technical computing. And technical computing is a term, as a euphemism that's used instead of scientific computing, because no VCs will fund anything with the word science in them. So really the concept here is if you really care about performance, if you care about linear algebra, it sort of goes under technical computing. And then business cares about SQL. So I saw a double disruption happening in these spaces. So I saw that the big data wave that was happening was transforming how traditional data warehouses worked, right? The Ralph Kimball stuff, the enterprise data warehouse stuff, that was all, of course, still relevant. Everyone still used SQL, but there's something more afoot. And it wasn't just NoSQL. It wasn't just Hadoop. Hadoop was the first stage. And what I saw was that there was a tremendous amount of white space that was going to get created in predictive analytics on top of all that data. Right? You can start by just counting things. That's a good start, but you can't end there, obviously. There's more business value beyond that. And there was a lot of white space. And then on the other side, what I could see through my consulting career in using Python for scientific computing and then business computing, what I could see was that cloud computing and the use of cloud and cloud adoption in business was absolutely going to be a game changer, which seems surprising in 2012 that one still had to make this argument, but it was absolutely still a relatively new concept at the time for people to rent supercomputers in the cloud to do their business processing, like the crown jewels of their analytics. They were generally keeping that very guarded in-house, right? They would build clusters in-house. They wouldn't think about spinning one up on the weekend. Most businesses were not thinking that. So I saw that both of these things would come in and dramatically disrupt what businesses demanded of their data and what they saw as their technical computing capabilities. And so whenever there's a new disruption, one has to ask, why? Well, why wouldn't the incumbents? Why don't they have a natural right to win? Why does a disruptor have a right to win? Well, the reason is the incumbents were really not loved. And this is a picture from a report that was done in 2013 or 14, like an investor report thing. And they went and did an NPS poll on existing tools for predictive analytics and advanced analytics. So outside of your BI stuff like Tableau or whatever, people were using SPSS, they were using SAS, and again, the data sort of speaks for itself, right? Whereas when they went and looked at Python-based things, there was a grassroots, completely invisible to most industry analysts, there's this grassroots upswell of things happening around Python. And through my consulting, again, talking to some of the most well-funded, well-capitalized groups in the world, which is like investment banks and hedge funds, what I could see was that they were needing the same things that the scientific computing people were needing at places like Procter & Gamble or ConocoPhillips. And it was ultimately around this persona of a domain expert. Of course, on Wall Street, they call them quants. But the idea here is that these domain experts, they want just actually a few things. They want to be unencumbered in how they do advanced analytics. They would go and get some data, they would go and try this, try that, they would plot some stuff, and they could tweak some stuff, and they write some code, and they do all these different things. It's a lab bench in a room filled with lab benches, stacked high of equipment, and they're just bouncing all over the place doing all sorts of cool stuff. Then once they got something working, they wanted to quickly share that thing, and precisely that thing, with their collaborators. They didn't want someone to come in and say, okay, let's go rewrite this in Java. We'll be back in 6 months with something that's completely not what you expect, right? They wanted just to have the thing they built, don't touch it, it works, and they want to get someone else to come in and take a look at it. So that rapid application development, that's actually a term, right? RAD was a term back in the 90s and early 2000s, kind of fell by the wayside, but it's a real concept, and it empowers these kinds of domain experts because their context and their ideas, they don't have to cross this air gap to a bunch of CS majors that don't understand calculus. So we saw that as the thing they wanted. And the last thing was all this capability, they wanted it in a way that integrated with their existing infrastructure, right? It couldn't have to, they could not teleport to some walled garden where this stuff all worked and then come back to reality and it all disappeared. They needed to speak to Java or C++ or Fortran or .NET or whatever. They really needed for it to at least have some semblance of integration. And the cool thing is Python checks all these boxes. Python just quietly gets out of your way unless you do a lot of these different kinds of things. I've seen geophysicists pick the stuff up in the space of an afternoon and get quite productive. And that was the kind of thing that really drove that grassroots adoption. And even Gartner was starting to recognize this in 2014. This is from their Magic Quadrant back then. And this is before they started sticking Anaconda in the lower left-hand quadrant, so it was quite a long time ago. But Alex Linden over there, wrote this up in his report. He said, what's interesting is that the innovative data scientists I talk to, they really favor open source components, like in Python and R. But of course, there's no vendor for Python. I guess there is a vendor for R, kind of, and we're of course a vendor for Python, but not the way that SAS is a vendor for SAS, right? Or MathWorks is a vendor for MATLAB. So there's no way for them to actually put it into their Magic Quadrant. They really couldn't get open source through this lens. But they did recognize there was something happening, even back in 2014. And a thing that was really interesting to me was I would go on to conferences, I would go and give PyData talks, and I try to give people some kind of a framework for understanding what makes Python different and special, right? Because again, people would say, oh, is this just like that Ruby thing? Or oh, is this the upstart competitor to R? Or I thought Python was just like Bash, all these things. But Python actually occupies a really, really interesting, unique position in that it can appeal to very different personas. And you can see, Python is maybe for a lot of professional software engineers, Python is the preferred language. But for many of them, it's not, right? For many of them, they prefer Java or C++ or C#. But if you give them Python, it's not so weird. Not the way that SAS or MATLAB is weird to a professional software engineer. And likewise, when you go to an analyst, right? If you give them some Python, if they're only used to Excel, a little bit of light VB, Python is not too intimidating. I mean, it's different. There's a little bit more stuff, but it's not so unapproachable the way that a pile of C++ is unapproachable, right? So Python, by actually hitting all of these different personas, it gives business groups, a real advantage when they start adopting Python technology. So these are all just things that I distilled, again, from sort of walking the streets and doing consulting work with this stuff. So that's kind of what it, distilling this down to then why Python, why did Python take over? Some of these things, right? It's easy to learn, it's got batteries included, you can do everything from visualization and data exploration to web scraping and coordinating, a bunch of clusters. And the community was very, very good. The community actually in Python is rather friendly and pretty welcoming. And there's one thing, people talk about this a lot, but there's one thing, a little thing that people also don't appreciate, which is that the Python virtual machine itself has a whole iceberg below the surface level of capability to interface with C++, C, and Fortran that is what allows it to do things in a high-performance way. So you think about it as a Honda Civic with mounting bolts for like the Enterprise's like warp drive, right? So it's a Civic, but then you import NumPy and Pandas, and like, oh, all of a sudden you're getting Intel MKL, right? So this is the kind of thing that also is, again, not so appreciated, but to a room of geeks, I'll definitely go into this. The fact that the Python interpreter, the CPython VM, not necessarily the most advanced VM in the world for languages, not V8, right? Not the JVM, all these things that had who knows how many billions of dollars dumped into them. But the CPython VM, maintained by volunteers, has this under the surface ABI that allows all these high-performance native libraries to interface with it, and that's one of its secret powers. So recognize all these things. 10 years ago, I started the company Anaconda. Of course, we're called Continuum Analytics at the time. But we also recognized that for this to work, we needed to rebrand the community a little bit. At the time, it was the scientific Python community. And then I said, you know what, we should probably rebrand this a little bit to PyData, because it's Python for data analysis. Obviously, we used tools and whatnot that were more specifically oriented towards business data processing. So we put on this little workshop 10 years ago at the Google Mountain View headquarters, and I called it the PyData Workshop. And we had all sorts of different people show up who are now, of course, when you look back, they're sort of like heroes of the ecosystem. But at the time, they were just our friends from the SciPy community. So you could have gone for, we charged, I think, $25 or $35 on Eventbrite for this thing. And you could have taken an advanced NumPy course from Travis. You could have taken a Pandas course from Wes McKinney, a visualization and matplotlib course from John Hunter. All of these things, it was amazing, right? There's actually, down there, you see there's a machine learning course taught by Jacob. And back in those days, we were calling Jake van der Plas Jacob, so that's how old this was. But it was a really good event, and this was the first of many. It was very popular, and we definitely struck a nerve, right? So since then, we've seen Python dramatically accelerate in adoption. A lot of really great things happen along the way to push it, to increase that curve. But when you look at the Stack Overflow polls and whatnot, NumPy itself, having as much popularity as .NET in terms of developer usage and mindshare and adoption, it's absolutely amazing. So that's kind of how we got here. And so now stage 2. Now enterprises start adopting your stuff, right? Good news and bad news. Enterprises are adopting your stuff in droves. And a lot of them have no idea what they're doing. So now what do you do, right? And this was something that I even saw in 2011 or so. But really now we're seeing where the entire industry around data analysis, everyone's using Python, and everyone has questions, and everyone has a talent shortage. So what do you do, right? So in this next section, episode 5, we're going to talk about what does that mean and what are the challenges. And to the theme of Data Council being a no BS data conference, there's going to be some straight talk in this section. So where does Python live, and what is the role of Python in this era where people are adopting MLOps? And I want to go back to this really interesting tweet from Paco Nathan just last month. And in it, it's a long thread. I recommend people reading it, which is why I didn't put a link to it here. That's awesome. But it's really great because he talks about the difference between frameworks and libraries and what's the difference. And he says again, he doesn't mince words here. He said, in professional IT environments, there's a tendency towards frameworks because they allow a priesthood to emerge around the management and the operations of the framework. Whereas libraries don't give you that so much. Libraries, a person just takes the library, does the thing, and now they've kind of gone off the reservation and done weird things. But whatever, it wasn't a framework. They could just load it, import it, deploy it, run it. But a framework, is something that IT can understand because it's sort of this thing. They have to kind of, operationalize it and colonize it and turn it into a part of the priesthood. So when I started looking at how Python was actually getting used in businesses, 10 years ago, it was people trying to get Java developers to write Python code, which doesn't work very well because they write Java in Python. But then that's kind of gotten a little better, but now we're still running into a new set of problems, which is all of the ops stuff, right? All of the coordination around machines and infrastructure and cloud and data and all these things. These are all clearly areas that businesses have had a long history of managing, and they have opinions on how they should be managed. And those opinions generally come up from the siloed organizational structures. Here's data management. Here is the infrastructure team. Here is the ops team. And they have opinions on what technologies you should be using for your management of containers. So when you look at how enterprises adopt tech, in general, the structure of the IT organization defines how they adopt it, not the actual technology itself. You could build the greatest machine learning system or library or whatever in the world, and when it hits the enterprise, people in the mature and laggard stages of adoption cycles, they're going to refract that into how they look at the world, which is this three-color way. And that siloization is going to kind of work its way back upstream into how you think about the architecture of your framework. And here is the problem. Most of the lift that we get in building unified frameworks around this stuff comes from the unification, comes from the fusion, comes from the fluid movement of context between the data management piece and the exploration piece and the operationalization piece. But as soon as IT takes it, they tend to refract it into these different components. They lose all the color in the middle. And this is where the hard talk comes in. What I've seen is most of the really big established businesses, their in-house IT teams, they don't get penalized for doing wrong things, right? And this is sort of like one of those hard truths that I've seen. For people who are innovators and young startup founders here, I want to give you this bit of hard fought knowledge. It's that they can actually be wrong, perpetually wrong, as long as they're not doing worse than their peers, right? And this is sort of a sharper way of saying no one got fired for buying IBM, which of course everyone's heard, but no, really literally, no one gets fired for doing the wrong thing. And so that whole thing about every morning, an antelope wakes up in the savannah. Well, as long as they hit their quarterly earnings, no one's budget gets cut. And so if you have to build better products and sell better tools into this kind of an evolutionary landscape, what do? Right? I had a really interesting, I had a lunch with the CEO of RStudio a few weeks ago, and he was griping to me about some, customer conversation he was having, and they were like, they're trying to figure out how to justify spending money on paying for RStudio Enterprise. And I said, look, Tarif, you have to understand, sometimes you'll be in a conversation with people who can be just wrong forever. So stop trying to convince them just because you're right. And he just had this almost like a Neo red pill moment. He just couldn't, he was like, oh my God, you're right. They can just do that. And this is why, fundamentally, why there is an adoption curve, why there is a chasm there. That chasm is a chasm of clue, right? And I mean that in the most loving way possible, but that is the innovators and the bleeding edge adopters, they are doing sense making on the basis of the substance and the fundamentals. People on the other side of the clue gap, they're doing sense making on sort of proxy measures, on adoption metrics they see, on what people are talking about, on what Gartner tells them is the thing in the upper right hand quadrant. And I mean, speaking of Gartner, right, they have this hype cycle thing. The reason there's a hype cycle, the reason why there's this inflated expectations and then a trough of disillusionment is because of this gap. So the thing, and this is kind of a weird observation, but it's something that as an open source advocate and champion for such a long time, something I think about, through open source and through crowdsourced innovation, we're going to be delivering more and more innovation faster, kind of exponentially faster than the world can absorb it, all right? So that means this curve is not static, right? Even as enterprise adoption comes this way, the fact that every single PhD in machine learning and AI out there is working together on open source technology to push the state of the art faster, it means this gap will just widen and widen. And when you have a wide gap like that, nature abhors a vacuum, people will vend all sorts of crap into the middle of it. People will sell all sorts of garbage. And if you're trying to sell good stuff in the middle of that gap, you have to be aware of the structure of your competitive landscape. So I call this sort of a semi-permanent condition because open source did revolutionize and transform how AI and data science proceeds, and it's really a crowdsourced movement now, right? It's not gated by only what Amazon tells us is good or only what SaaS tells us is good. Lots of people are doing all sorts of cool stuff. And so this gap will continue to widen, and there's this clue gap. And kind of coming back to this point about, most of you are probably familiar with Conway's law. My corollary to that is that the kinds of systems that will stick around in that clue gap, the things that stick, will be things that conform to the budget structure of the maintenance teams within IT, not the build-out teams, not the CapEx teams, the OpEx teams. So you have to be very aware of this dynamic because y'all are building and selling all sorts of data management frameworks and MLOps frameworks. Really, really think about this, right? Ultimately, businesses are not going to, they will shift very slowly how they're organized internally, how they organize their budgets, how those IT teams report up to the CFO. Those things change very, very slowly. It's really not your business to change those things. So if you want to sell into that space, you have to just be aware of that dynamic. And the way I talked about this years ago was that I saw this tension that was happening because people would come to me and they say, "Look, Peter, we're part of this data science group and all sorts of good stuff is happening, but can you help us deal with IT somehow? Because they're not getting us the tools we need. They build us one Docker image and tell us everything must run off this blessed Docker image. They won't let us install this. They won't let us install that. But they want us to go and deliver solutions. So what are we supposed to do?" And ultimately, I came to this formulation of sort of an exploration versus production divide. Because data science, of course, you can sort of look at that as an exploratory data analytics activity, right, in the style of John Tukey. And then most of business IT dwells on the production side. And so production has a very different set of concerns. And the point I want to make with this slide is that there's not a wrong side here, right? If you are tasked with managing production, you will absolutely take this particular point of view, right? You want to manage data, secure it. You want to govern who has access. When you look at infrastructure, you're responsible for the spend. Right? You can't just go and tell the CFO, "I don't know how much we're going to spend next month. Call me back in 30 days, right? You have to actually have some planning around this as well. So they have an unenviable problem to solve on the production side, but when you're sitting squarely in the exploration side and you're told, "No, please give us AI, but no, you can't buy a GPU. Can you use this 5-year-old HP laptop?" Right? It's very frustrating to have empathy for the other side. So I was using this kind of framing, exploration versus production, and then I realized this isn't actually the correct framing. The better framing is pioneers versus settlers. So what data science, as it started going into the business and going into enterprises, the people who are adopting data science in the 2013, 14, 15 timeframe, those sorts of folks were pioneer sort of people. They liked what was new. They liked doing cutting edge things. They're pioneers. They go into these businesses who want to bring in innovation, and everywhere in existing solid businesses, publicly traded businesses that have to hit their earnings reports, everywhere is a culture, a settler mentality, right? You want things stable. You want things predictable. You want to know, here is the budget for innovation. Please don't let innovation exceed this line on the floor. And then everything here is very well modeled on this spreadsheet. So in this point of view, settler versus pioneer, you're solving for different kinds of objectives. You're taking a different kind of approach to life, actually. One is about fear mitigation. One is, the settler folks are about mitigating dangers, and they're really about how can we manage the bias. If you're familiar in statistics with the bias variance trade-off, how do we move the bias? Maintain to it, decrease variance, and then increase that bias, 2% every quarter. And so it's a very, very it's an operational way of thinking about things, but it's a very low variance kind of operating mode. And if you're a pioneer, you're all about the variance, right? You're like, hey, can we get more variance? And then you kind of YOLO into it and see what happens. And that is essentially the underlying struggle between sort of data science exploratory groups and then the production groups. It wasn't really about, are you in production or are you doing exploratory analysis? It's really about the mentality and the mindset of the people who are getting involved in this stuff. And the reason to sort of talk about it this way is because it is absolutely possible to have a pioneer mindset in operations and in production. And you can also end up with a bunch of settler mentality in exploratory areas, right? So the mentality is orthogonal to the actual activity itself. So we can talk about, even I have famously tweeted some very, snarky things about exploration versus production. But I'm going to try to adopt this frame in the future about the different mentalities, because we can absolutely, if we all want to keep having these kinds of conferences and keep having jobs doing what we're doing, data science and all the Python stuff, it's got to make its way into production. But how we actually talk about the friction, how we talk about the right ways to think about it, we have to upgrade our thinking there. And at the one thing I think is really at the heart of the issue, and I'll get to this kind of in the next section as well, the question of scale, right? This is a term that gets thrown about all the time. Everyone talks about scale. And in the operational and settler mentality, you care about understanding the scale of the operations, really an OpEx scaling kind of thing. You think about how do we reduce the cost of risk or the amount of risk that we take on. So ultimately, even when you think about how that affects software engineering, right? If you work in-house as a software engineer at some big company, there will tend to be there will be a tendency to adopt tools that treat the human resources even as fungible labor, which anyone who has done software engineering or done coding for fun, in their own time to make cool stuff, knows that it's not fungible, right? No more than music or poetry is fungible. Software is a deeply creative activity, and it requires a tremendous amount of focus and flow and context, and it's fun. It's joyful, right? Joy doesn't show up on a spreadsheet anywhere. Right? Joy just sounds like you're going to go off and YOLO some random new tool off of NPM that's going to blow up production. So when you look at how businesses, what business IT operationalization of the software coding activity looks like, you can also say, well, data science will probably end up in that mode too, unless we do something about it. Right? And we can't afford to let that happen for data science, because ultimately, I believe that all of the things that we're doing with these data tools, they're really about doing a scientific transformation, a computational rationalism transformation of business, right? It's really digital transformation. So this stuff is, by its very nature, it's science. It's high variance. You cannot take this kind of static settler mentality towards something that's fundamentally scientific. So another way to think about scale is, what if we flip this around and say, how do we scale the power and the impact of a single individual, right? If we're at Fortune 2000 company FUBAR, and here at FUBAR we just started a data science center of excellence, and by hook or crook we managed to hire like one of the brightest data scientists in the world. If she comes in, how do we not make her rage quit in 2 weeks, right? How do we make her the most powerful person at the company? How do we scale the impact and the creativity and the genius of one person? How quickly can she go and access all the data systems she needs to? How quickly can she go and spin up the GPUs she needs to do a certain amount of AutoML or something, right? How accurately can she make a prediction if she were to move that fast? An interesting thing, because we're here now at the end of, maybe not the end, but we're here in a lull in COVID, right? And what was shocking was the beginning of COVID, Moderna came out, and in 2 days they had sequenced the genome, or they had an mRNA vaccine candidate produced in 2 days in March 2020. And it was, the FDA process and the testing, all these things, there are things we need to do, obviously, but that is the process that drew out for years, right? So, or months and months and months. So likewise, in every organization, every business, there's a book, what is it? Islands of Blue in a Red Ocean or something like that, talking about how most businesses have a few profit centers, everything else is just an ocean of red ink, just like everything else loses money. There's a few heroes, a few heroic little efforts or products or initiatives that actually make all the money, all the alpha, and then everything else is just drag, right? So this question is just sort of a little thing to take home and think about. What would my organization do differently? How would we be different if we were trying to optimize for the efficacy of a single individual? And I won't get too much into this, but the concept of individual creativity, individual genius, all of this comes down to having slack. Right, having a bit of space in the system, having some slack, giving people the space to be creative, and really importantly, removing fear, right? Letting intelligence go into the leaf nodes, giving them the slack to do the right things. This is in almost every way the antithesis of sort of modern business management, certainly modern IT management approaches. And so to go back to the Star Wars theme, it's sort of like we started off with a rebellion that was about a few individuals with lightsabers, and we ended up with everyone having to basically line up and go into a giant Star Destroyer. And the only way we do anything is by driving a Star Destroyer there. And really all the data science rebels wanted was just a better lightsaber, maybe a waterproof one or something. So the last section, what does the future hold, right? If how Python got started was all this joy and creativity in the rebels with lightsabers, and then in the middle of it, the Enterprise shows up and says, oh, we have all these Star Destroyers. Please find yourself a seat. What does the future hold for us? And I think of it as the return of cybernetics. And I mean that term very precisely in the very traditional definition of the term. So I don't think we can allow this incredible, interesting moment to just get diffused into a sea of just normal, classic business IT management. right? We have to look at the fact that there is going to be this perpetual chasm between what the innovation space is delivering faster and faster and where businesses can adopt kind of clue. And this clue gap, again, it increases over time. The Lyapunov coefficient is our worst enemy in this case. So I think these things will continue to be the case. Like, basically, data scientists will continue to be underserved. The C-suite will continue to get hammered with messaging and hype about AI. Are you doing AI yet? Are you doing quantum AI? Are you doing quantum AI on a blockchain, right? It's going to be more and more of this kind of stuff. And ultimately, all of the things that, whatever little islands we build, islands of quality, things that work, they're going to get just washed aside by this. And everyone's going to be miserable and everyone's going to be suffering. And the thing that we have to do to get around this is we have to just understand what is it that gave us this exponential innovation. It's crowdsourcing. It's peer innovation, peer education, peer motivation. So maybe what we should do is actually crowdsource the education as well and really lean into this idea that if we want all the things that we cherish, that we hold dear, and that we love, if we want those things to actually continue to be relevant in the business context, we have to then take on, as a first-class concern, as a community, we have to take on the task of getting everyone literate, getting everyone up to speed on what this really means and what is good. So the reason for this is because the future that comes is the past that's been, right? What's pictured here is an analog computer that was the main gun targeting computer on the Iowa-class battleships. And this is the origin of cybernetics and computing. Modern computing, a lot of it, was in prediction systems, anti-aircraft control, and gun sights and things like that. Very martial in nature. But ultimately, we had an interlude of 25 or so years of transaction systems and PCs and all this great stuff. But now we're back to people caring about performance again, people doing vector computing again, people doing linear algebra again in a business environment. And we're entering into an era of connected data to actuation to sensing, and then a loop that runs this whole thing faster and faster. And that is cybernetics. So the future doesn't just look like AI, it's actually computational decisioning. And so it's a decision loop. And it's the observe, orient, decide, act loop, and it's about running it faster than your competition. This is just fundamentally what it will be and what it is. Right now, everyone struggles with literally every stage of this loop because they're still thinking about it from a traditional IT management perspective, which is, again, that siloization of data and infrastructure and code, and then this weird data science stuff showing up in the middle, right? But all of it actually is integrated in this loop. And in order to actually manage the whole thing, you have to take a holistic approach. Fundamentally, correctness. What is correct? Right? What is a valid test for this system? It depends on what you see as the scope of the system. If it's just a function, then a function test is sufficient. But as an entire predictive system, then the data inputs are actually an important part of the test. You could not change a line of code in GitHub and still have a system that breaks from today to tomorrow because the environment changed, because your training data is no longer matches the operational environment, right? So we actually have to look at performance, the data values themselves. Those are aspects of correctness. And when we think about change management for this whole system, our ability to be agile is also an aspect of correctness, right? There's no military on the planet will buy a missile that goes faster and faster once you launch it, but has no targeting system to correct when the target moves. Your ability to retarget is absolutely as critical as your ability to get to the target in time. So we have to look at all of these concerns, these classical silos, in one fused system. This is the future. So I'm running a little short on time, so I'll put all these up at the same time. What I think of as Zen of cybernetics is you've got to be respectful of the different components of this. They all work together. They're not, but they're somewhat orthogonal. You've got to understand in the middle how good is your computer and what does a good computer look like, and when should you actually try to go and do a distributed system. You got to understand data. You got to understand that data is almost always the result of having some other model or some other thing produce the data. So you got to have the whole chain of it, right? And then you have to understand your organization, right? I'm going to quote the author of The Little Prince here. He wrote, "There's but one veritable problem, and that's the problem of human relations." You'll not get anything done unless you're able to get all the stakeholders on board. And to understand the stakeholders, you have to understand their budgets and their compensation structures. And only if you map that out can you get to success. It's not about the code. It's not about how many queries you do per second or what the latency is in your Lambda architecture. It's about actually how can the business absorb this thing I'm trying to give them. And if the thing you do is any good at all, it will be a fusion of things, but they don't really know how to fuse. So in order to actually bring about the cybernetic age, we've got to understand the fight we're in for. We understand why we fight, which is to get everyone in the world able to do these kinds of things and to sustain this innovation path. And then we have to know how to fight, right? We have to know what exactly are the challenges that we'll run into and how to talk about these challenges with all the other stakeholders. Thank you so much. Thanks, Pete and the team, for putting this event on.